Hi guys, today let's talk about the ARP protocol. What is ARP? It's Address Resolution Protocol, right? ARP protocol is especially used for the network device to resolve its next hop's MAC address, right? Remember, when the PC want to send something out, right, you need to know the layer 2 header so that you can encapsulate the packet, then send it out, right? For the destination MAC address, right, if it's not in the PC's ARP table, and then the PC need to resolve the destination MAC by using this ARP request. It's automatically resolved, right? But you need to send something out so that to trigger the ARP request. Okay, so at the beginning, when the PC boot up, its ARP table is empty. Right now, see that? No entries in the ARP table, right? Then let me do a ping from PC1 to PC2 so that PC1 can learn PC2's MAC address in its ARP table, something like this, right? IP address and MAC address, they are all one mapping, right? Okay, let's start. In a simulation state, you need to select ARP, and also let me click the ICMP, right? Because I'm going to use Ping, right? Ping is a ICMP protocol, okay? And then Ping is working on layer 3, ARP is working on layer 2. Okay, let's start, right? Ping 192.168.1.2. See that? You see two packets sent out. One packet is the ping, the other packet is the ARP. Because it doesn't know the PC2's MAC address, you need to learn first, and then so that it can construct the ping packet, right? So let's take a look at the first packet. It's an ARP request. See that? ARP process constructs a request to the target IP address. So that's a layer 2 protocol because it only has layer 2 header, right? Layer 2 header, in the layer 2 header, it is like my MAC address is .111 and send it to a broadcast MAC address. It's all ones, 6 bytes, all one. It's FFF, right? And then the message body is like this. My IP is .1, your IP is .2. Please return your MAC address. Something like this, right? Okay, let's move forward and check. The ping packet will be on hold, right? Before it learns the MAC address, and the ping packet will be on hold. I send to the switch. Coming into the switch, no change. Going out to the switch to all the other ports. See that? /2/3/4/5, right? Because it's a broadcast message, right? A broadcast means it one receive, broadcast to every other. Okay. The switch broadcasts this message out to all these devices, but only PC2 accept it and will reply because these guys found the message body is not targeted to them, so they discard the packet. So let's see this. It is coming in from faster Ethernet 1 and going out, reply, right? When it replied, you know the layer 2 header is going to be the PC2's MAC address and PC1's MAC address for the destination. And the message body also switched. My source IP is .2 and your IP is .1. Okay. We will go back to the switch and to the PC1. Then PC1 receive it, right? And then PC1 receive it means it learn its PC2's MAC address so that it can construct the ping packet. Now ping packet sent out. This is not correct, maybe. Okay, ARP process takes out this packet. Okay, let's move forward. Let's take a look at the ping. Right, it's PC1. The ping is not going forward. It's not moving forward. Okay, let's move forward here. See, the ping is out to the switch, right? Now it's a unicast ping, right? Source MAC, destination MAC, source MAC, destination MAC on the switch, and we'll reach to PC2. PC2 receive it, right? Now you can see the layer 3 header, right? Because this switch only works on layer 2. You don't see the layer 3 header on this switch, but when it reaches to the PC, you see the layer 3 header, right? Coming in is like .1 try to pin .2, right? See, it's the ICMP process received, and layer 2, right? Layer 2, everything is null, and return reply the ping, right? Reply the ping, just switch over the headers. Switch over the headers, and we'll send it back to PC1. PC1 receive one pin packet at least, right? And see that pin packet is a unicast pin. Let me see if I get anything. You see that got one reply, right? It will eventually got 4 reply. This is another pin packet sent out. Let's see, when you get reply, it will show up the other one. Reply 1. See that you got 2. And move forward. Totally 4 packet. Totally 4 packets. See that? Pin finished, right? Normally it will send out 5 packets and get 5 reply, but since at the beginning, right, you need to learn the MAC address, it dropped 1 packet of the pin packet because it was on hold. Takes so long time to learn the MAC address. And this is one of the ARP process, right, from PC1 to PC2, right? Obviously, these two PC are in the same local area network because their IP are in the same subnet, right? But what if you try to reach to a device that is not in the local area, right? For example, PC3 want to pin this server, DNS server 10.10.10.10, right? Then the ARP request will send target PC3's gateway IP, right? Because the PC know the destination is another subnet. Then PC3 will reach to its gateway to learn its gateway's MAC address, right? And then let's see, right? Let's test it on PC3. Okay, let's see ARP-A. PC3, there's nothing, right, in its ARP table, right? And then let me do a ping 10.10.10, right? You check the ARP process. This time, it's also 2 packets sent out, right? Let's see, this packet is the ARP process, right? So see, the ARP process is target.254, which is this port's IP address. Because PC3 know 10.10.10 is not in the same subnet, then PC3 need to send the packet, ARP broadcast the packet is also broadcast in the local LAN, target its gateway's IP. Because eventually this ping packet need to send to this router, and then the router will forward the ping packet to the server, right? That's why PC3 need to learn its gateway's MAC address so that it can encapsulate the ping packet. Okay, it's still a broadcast packet, right? Let's move forward. Move forward. See, it's still broadcast, but to everything else, only the gateway router accept the packet when we reply it, right? Same, right? The gateway router has a MAC address of AAA and reply to 333, right? And source IP is .254, destination IP is .3. That's the reply. Okay, let's see. This is only layer 2 header, no layer 3 header, right? Okay, be aware of that. Okay, now it got the MAC address learned, AAA learned in its ARP table, and then it will send out the ping packet because the ping packet was initially hold off, right? Now let's see, move forward. Let's check the router, okay? See this ping packet is the layer 3 ICMP, right? Protocol package, right? So the source IP is .3 and destination IP is 10.10.10. Now the router will forward this packet to 10.10.10, right? Where is 10.10.10? 10.10.10 is here. So the router will forward the packet into another router. This router will forward the packet to 10.10.10, okay? Eventually. See the layer 2 header, right? Layer 2 header, right? The incoming is source is 333, destination is AAA. AAA is this port MAC address, okay? And then when the router send out on this port, will switch, not switch, okay? It will replace the layer 2 header, right? Remember, every hop of the router will rewrite the MAC header, right? Use its own MAC address and the peer MAC address, rewrite the layer 2 header and forward it out. But the layer 3 header won't be replaced or rewrite, okay? Get to this router, still same, right? But the layer 2 header got replaced, see that? And reach to this server, okay? When this server will reply its ping, okay? See that? Source become 10.10.10, destination become .3, and layer 2 header switched, right? We move quickly, okay? See that? One ping is back. One ping is back. Now you got one reply, right? Still, you get totally 4 reply because the first one is dropped because the time for that is to look for the MAC address of this gateway, right? Then the first ping packet was dropped, right? Okay, I think that's for today, right? So remember that the ARP request, first of all, the originator will look at the destination IP, right? If that destination IP is in the same subnet as the originator, then the ARP request will directly go to the destination IP. But if the destination IP is in another subnet, like this one, and the originator will send the ARP request target to its gateway's IP address here. So the gateway will return its MAC address to the originator. In that case, during the ping, packet is being constructed, and the layer 2 destination MAC address is going to be its gateway's MAC address, not the final destination's MAC address, right? So there's something like originally the PC need to determine if the destination is in the same subnet or not in the same subnet. Then the ARP request will be request to different IP address. Okay, I think that's it. Please like and subscribe. Thank you very much.